Okay, welcome back, kiddos. Now we are working with Unit 7. So we're going to talk about polygons. Okay, so this is what we're going to be talking about today. So let's get right into it. All right, so we're going to talk about specifically not only polygons, but the angles of polygons today. So our essential question is, what's the sum of the measures of the interior angles of a polygon? Okay, so let's start by talking about what a polygon is. Okay, so a polygon is something that looks like this. Okay, so that means it is a closed shape with straight sides. Okay, so it's a closed shape like this, and it has straight sides. So this is a polygon. Okay, this is not a polygon because this one has a curve. So this right here, this part right here tells us no, it's not. Okay, because it has a curve. Okay, and then this one. This is not a polygon because this one's open. So because it's open, it's not a polygon. Okay, so that's the main thing, how we can tell it. So polygon has straight sides. All right, closed shape. All right, so let's talk about how we name a polygon. Okay, so when we name a polygon, so if we see this polygon right over here, we're going to list the vertices in consecutive order. Okay, so the vertices are the corners. Okay, so let's take a look at this one. This side right over here, okay, this side goes between B and C. So we're going to call that side BC, right? It connects those two together. Okay, so the vertices are the corners. So this is one vertex, so that's going to be called D. This is another vertex E, A, B, C, right? But we said it's going to be in consecutive order. So we're going to start at A, and then we're going to go around. So we're going to call this A, B, C, D, E. And so we're going to call that polygon A, B, C, D, E. Okay, and then it's classification. All right, so how do we classify it? We classify it by the number of sides. So the number of sides determines its name. Okay, so let's look at this right over here. What would we call that? Well, let's first the number of sides. Okay, so 3 sides. We call that a triangle, right? Okay. What about 4 sides? 4 sides is a quadrilateral. Okay. 5 sides is a pentagon. Okay. 6 sides is a hexagon. Okay. 7 sides is a heptagon. Okay. 8 sides is an octagon. Octagon. Okay. 9 is a nonagon. 10 is a decagon. 12 is a dodecagon. Okay, and then what if it's a number that's sides that are more than 12? Okay, so if we say n, where n is the number of sides, we just call it a n-agon. So we might call it a 13-agon or 14-agon or something like that. Okay, so these are the names. So polygon ABCD is classified as what? Which one of these would we call it? Well, it has 1, 2, 3, 4, 5 sides, so it's called a pentagon. So it's 5 sides. Okay. All right, so that's how we name a polygon. We're going to call it in by the vertices in consecutive order, just like over that. The number of sides determines its name. So since this one's 5 sides, it's called a pentagon. Okay, so then there's different types of polygons. We're going to talk about the first one. It's called a regular, and then it's irregular. So if we see these right over here, this one's regular and this one's irregular. Okay, so the difference between the irregular and irregular, a regular polygon is equilateral. Okay, that means all sides are congruent. Okay, so that means this side, this side, this side, this side, and this side. Okay, and then it's equal angular, which means all angles are congruent. Okay, so if we said that this was, say, 2, this would also be 2 arcs, right? That would also be 2 arcs, and that's how we indicate that these are all the same. Okay, so all the sides are congruent, which means they're the same length. All the angles are congruent, which means they're the same measure. Okay, so if it's irregular, that means at least one side and one angle are different. Okay, so this is irregular because we can see this side is different from this side, right? So at least one side, and then this angle has to be different from this angle, right? Those are both 2 different angles. Okay, so that's the difference between a regular and an irregular. Okay, then so if it's not regular, it has to be irregular. Then we talk about concave or convex. So this is convex right over here. Okay, and this is concave. Okay, the difference between convex and concave is this caves in. It caves in. Okay, so concave, convex have all angles pointing outward. See, this is pointing outward. Okay, concave polygons have at least one corner pointed inwards. Okay, so that's the difference between convex and concave. Concave means it caves in. All right, so the first thing you need to do is go ahead and do your practice on Delta Math to where we identify these polygons. Okay, once you've done that, let's move on to the next page. All right, so let's take a look at this next page right over here. Okay, so now let's talk about the interior measures of a polygon. Okay, so interior, right? We know interior means inside. Okay, interior means inside. Okay, so the using the interior measures of the polygon, let's start by saying, let's say that n is equal to the number of sides. Okay, so that's what n means. N means the number of sides. Okay, so let's keep that in mind. All right, so here's how we calculate the interior angles of any polygon. Okay, the sum, okay, that means the total. The sum of all the interior angles of a polygon is always going to be equal to 180 times n minus 2. Okay, and we said n is the number of sides. Okay, so that's going to be equal to 180 times the number of sides minus 2. Okay, number of sides minus 2. Okay, next, each angle is going to be 180 times n minus 2 divided by the number of sides. So 180 times the number of sides minus 2. We're going to put that on top, and then we're going to divide by the number of sides, and that will give us each interior angle, so each one. Okay, so this applies only to regular polygons, only to regular ones. That's the only way you can do that. Okay, then we're going to talk about the number of triangles that can be formed from the given polygon. So we'll show that in just a moment, but that's going to be equal to n minus 2. Okay, because a triangle is equal to 180 degrees, right? We remember that. 180 degrees for a triangle. All right, so let's get right into some practice. We're going to say to find the sum total of all the interior angles, we're going to take 180 times n minus 2, where n is the number of sides. Each angle, we're going to take 180 times n minus 2 divided by the number of sides, and then the number of triangles is just number of sides minus 2. Okay, so says, what's the sum? Let's look at this first one. What's the sum of the interior angles of a pentagon? Ooh, pentagon. So what do we know about pentagon? Pentagon means 5 sides, right? We know that from our practice right over here, right? We said a pentagon is 5 sides. So what's the sum of the interior? The sum, we're going to look at this column. We said it's 180 times n minus 2. Okay, so if it's 180 times n minus 2, right? That means, let's put that here. The sum, that means the sum is going to be equal to 180 times, we said the number of sides is 5 minus 2. Okay, so if we put this into our calculator, okay, that is going to give us the answer of 540 degrees. Okay, so all we have to do is put that into our calculator, and then we will get that final answer. Okay, so next. Yes, we're going to put it on our calculator. All right, next. What's the measure of each angle of a regular 24-gon? So 24-gon means 24 sides, right? Okay, so the sum of each angle, it says each is going to be 180 times n minus 2 over n. So each is going to be equal to 180 times n minus 2 over n. Okay, so that's going to be equal to 180 times 24 minus 2 over 24. Right? We said it's the number of sides, which is n. Okay, so 24 minus 2 over 24. Okay, so we are going to put that into our calculator. So if we do that, that's going to give us 165 degrees. Okay, so the main thing is that we have to let's go and highlight that. Main thing is that we have to just recognize which type of formula we're going to use. All right, so we look at those keywords. So this one said sum. Okay, and then this one said each. All right, now, next, number 13. What is the sum of the interior angles of the polygon below? Okay, sum of the interior angles. So sum of the interior angles is this, 180 times n minus 2. So the sum is going to be equal to 180 times n minus 2. Okay, so that's going to be equal to 180 times something minus 2. And n is the number of sides. So let's count the number of sides. We can say 1, 2, 3, 4, 5, 6, 7. Okay, so 7 sides. So that means it's going to be equal to 180 times 7 minus 2. Okay, so if we put that into our calculator, right, that into our calculator, that will give us the answer of 90 degrees. I'm sorry, 900 degrees. Okay, so that's our final answer, 900 degrees. That's the sum of the interior angles, okay, of a 7-sided figure. Okay, next, let's look at a different one. So this one, they don't have pictures. This one, they do. Okay, what's the measure of each interior angle of the regular polygon? Okay, so each, it says it only has regular, so that's what the formula is going to be. So each is going to be equal to 180 times n minus 2 over n. Okay, so that's going to mean it's going to be equal to 180 times something minus 2 over something, right? So we need to figure out n, which is the number of sides. So let's just make it a little larger and count those, okay? We can do this. Let's see here. We're going to say that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 sides. Okay? So we're just going to put that 14 into our formula. Right? We're going to say 14 right there. And we're going to say 14 right there. Okay? So then if we put that into our calculator, right, that's going to give us the answer of approximately 154.285, and it says round to the nearest tenth. Okay, so that means we're going to think, right? We're going to underline the 2. We're going to ask the 8 what to do. So that means it's going to be approximately 154.3 degrees. Okay, 154.3. All right, that's it. All right, let's keep it moving. It says next, using diagonals from a common vertex, how many triangles could be formed from a 13agon? Whoa. So the number of triangles formed is n minus 2. Okay, so that's going to be, so the number of triangles is equal to n minus 2. So that's going to be equal to, it says 13 sides, so 13 minus 2. Okay, so if we put that into our calculator, right, that's going to give us the answer of 11. Okay, so 11 diagonals. Okay, so what does that mean? Okay, so now that we have a picture, let's take a better idea. It says, using diagonals from a common vertex, how many triangles could be formed from the polygon pictured below? Okay, so using diagonals from a common vertex. So we can do 2 different ways. One way is to draw it. Okay, the second way is to use n minus 2. Okay, so the first way, let's do the first way. If it comes from a common vertex, so it goes from here, a diagonal goes across to another corner. Okay, across to another corner. So from here, I'm going to go down to here, right? Okay, so then common means we use that same one again. So now I'm going to go from here to there. Okay, so since it's common, I'm going to use that same one. I'm going to go from here to here, right? These are all the vertexes. Okay, now the next vertex would be right there, so I'm going to go right there. Next vertex is there, so I'm going to go right there. And then I can't draw to that one, right, because it needs to go across it. So now it says how many triangles can be formed. So we got to count those number of triangles. So let me just change the color. So I'd say 1, 2, 3, 4, 5, 6. So with with answer number 1, if I draw it, I could draw 6. Right, now if I did number 2, the second way, I would say the number of sides minus 2. So if I said the number of sides minus 2, that's going to be equal to, let's count the number of sides. So right, I would say 1 side, 2 side, 3, 4, 5, 6, 7, 8. So that'd be 8 minus 2, which is still equal to 6. Okay, so either way, we get the same answer. Same answer either way. Same answer either way. All right, so those are our practices. We're just going to use this chart right over here, okay, to figure out the interior angles. We're going to use that, and then we're going to use this chart right over here to figure out the how we classify those polygons. All right, so we got this. If you have any questions, just let me know. Let's make sure we get a great grade on this for first grade.